What's up, all? Glazer here. Good to see you. This is a little explanation for Thursday's lab for week 2, the Pendulum lab. This is a example of the lab that we would set up in class, like pretty much exactly like this. Unfortunately, you'd be able to feel the pendulums and actually swing them. It's one of my, I love pendulums. You all know this. I could teach a whole class on pendulums, at least like a quarter on pendulums if I wanted to. This simulation is actually really nice because it records all the data for you. It times the period for you. It does all this stuff that is, a little tricky to do in an actual lab setting. So here we go. I wanted to just explain a couple things. Also, physics update, started watching the Nova Planets series last night, which is pretty killer. It's on Amazon Prime. So if you're looking for stuff to watch during your shelter in place, just watch the first episode, which is about the 4 rocky planets, right? Mars, Mercury, Venus, Earth, and Mars, if we start from the sun and go out. And kind of really how they came to be and where we think the future trajectory is headed for them. Super cool. And I hope you caught that pun as well. Okay, so let's get to the Pendulum lab. This is a Google Doc. You're going to be filling in the answers on your Google Doc, okay? And I'm going to present this so I can show you the lab. I think I'm now presenting the screen. Okay, so this is the Pendulum lab that you need to be seeing. I'm going to try to go full screen here. I think you can see that now, okay? So you're going to start with the lab. Actually, the only one you're using right now is the lab, okay? So this is what it looks like here. You got your pendulum in the middle of the screen. Up on the top, this is essentially like a protractor, okay, which will tell you the angle that you're pulling the pendulum, right? You got some controls over here where we're not actually using any of this. We are going to use the period timer, which is right here. Okay. So first one, you let it go to an angle of 30 degrees, which it tells you right on the top of the screen there, and you let it go. Okay. And you'll get your pendulum going back and forth. This is a perfect physics world. There is no friction or air resistance, so this thing will just continue to oscillate, to swing forever. Okay. Then one of the first questions asks you, what's the period? You have this little clock right here. If you hit play right there, it will record 1 period for you right there. Okay. So did I do this right? Yeah. I think I did. Okay. So that'll give you the period right there. And notice what it's recording, right? It's recording from, well, hold on. Can I go back? Oh my gosh, sorry. Let me go back to. All right. It's recording, I think this worked, right? The period of a pendulum, which is the entire oscillation, which a lot of times we talk about if you let the pendulum go here, right? It's going to swing this way, and then it's going to swing all the way back. And that's one oscillation, that's one. The time it takes for the pendulum to do that is the period of the pendulum, okay? So if you let this go and it goes 1 second, 2 seconds, all the way back, you say the period of that pendulum is 2 seconds, okay? The lab is recording it a little differently, but it's still recording the same thing. It's actually starting it in the middle, okay? So if we let it go here, the lab starts the period timer when it goes right here. It says go, and it goes this way, and then it goes this way, and then the timer stops when you get back to the middle, okay? So same idea, still giving you the period, just measuring from a slightly different part. All right, so now I'm gonna go back here. Hopefully this is working. That's not what I want. I want this, okay? All right, so what else do we got? So that's how you're gonna record your time, and then it asks you for frequency as well, okay? So frequency is the inverse of the period. Period is measured in seconds, right? It's how long it takes the pendulum to swing one way and then swing all the way back. Frequency is measured in hertz. And remember, hertz is a unit that is actually 1 over seconds. How many times per second how many oscillations per second does that pendulum make? So for example, let's go back to our 2-second example. I think you can see me in the little screen here, right? If this thing takes 2 seconds to make a full oscillation all the way forward and all the way back, Okay. And then I said, what's the frequency of that? How many times in 1 second does it make a full oscillation, right? Well, if the period is 2, then your frequency is 1/2 or 1/2. And that makes sense, right? If I let this go, after 1 second, it will be right here, which is half of an oscillation, right? So it has a period of 1 second, 2 seconds, and it has a frequency of 1/2 hertz or 1/2 hertz. So you need that for the sheet. It's pretty easy. You time your period using this clock. You take a calculator. You can use one online if you don't have one at home, and you go 1 divided by the period, and you round your decimals, and that's your frequency. Okay. All right. So what else do we need to test with this? So you're going to change the mass. First thing you change is the mass, and that is right up here in this upper right box right here. You slide the mass. We ask you to list the mass values you test. So, test 2 or 3 mass values. I would say 3 is a good number. And for that, you're going up to your 30-degree mark. You always have to make sure you're dropping it from the same point. Okay. All right. And then you test the length. Okay. So you remember you can always pause this or stop it. Okay. You test the length. You change the length right here. You can change the length of the string. Okay. So if we make it longer, and we go up and we drop it from 30 degrees again, what happens? Okay. Oh, we did see a difference there. All right. And then let's see, what else do you change? And then you change gravity, right? So you can actually change gravity with this thing, which is right here. Oh, I see. My values were not. Your values are going to start a little differently. Okay. And then I'll change length too here. And then still going from 30. Okay. And if we do that, what happens? All right, so see what happens with gravity as well. And then for number 10, then we're having you measure 4 different options with the length, right? So we're gonna have you look at 0.2 meters, 0.4 meters, 0.6 meters, and 0.8 meters, okay? We're gonna ask you what pendulum gives you the highest frequency. Remember, they're inverse. So the highest frequency is the lowest period. Okay, that's the pendulum that's going back and forth very fast. Okay, and then we ask you some things about doubling the period. If you double the period, does it cut the frequency in half? What has to happen to the length to double? Basically, like if you double the length, is that doubling or having the period, or is there some other relationship between the length and the period of a pendulum? And we'll talk about that in a future video. Okay. So let me see this. I'm going to get this back to my screen here. All right, that's me. So that should be good. Again, these labs were pretty straightforward this week. I really think by watching the videos and answering these, you should be good. I will send out information about office hours on Friday. So if you have questions on this, you can hit me up in the office hours on Friday. But please, well, you're ready. I was going to say watch the video. You're ready to watch this video. Yeah. And hopefully this makes sense. And I'll talk to you soon. Take it easy. Goodbye.